Welcome to LNP Renewable System Integrator. Today we are going to discuss about how automation is established inside the ships using PLCs and with a real-time examples. So in this topic, today's discussion we are going to find the answers for these 8 questions. One is that how a engine room automation system is monitored and controlled. How a fire alarm system and a fire reduction system is monitored and controlled. What happens when fire is detected on onboard ship. How a generator control system is monitored and controlled using PLCs, and how a cargo pump control system is monitored and controlled, and how a ballast control system is monitored and controlled using the PLCs, and how navigation and the wastewater management system is monitored and controlled using the PLC in the ship. And most importantly, our important topic, that is HVAC system, how it is being monitored and controlled using PLCs in the ship. So engine room automation. It is a complex system which controls and monitors the ship's engine, generators, fuel system, and other equipments inside the engine room. Say for example, using the PLC program in the engine room automation system, it is responsible for controlling the start, stop, speed control, power control of the engines, generators, as well as monitoring the fuel consumption, temperature, pressure, and other parameters. So in the engine room control system, so it is equipped with a tailor-made total concept. We have so many categories in the automation system. One is the universal monitoring and control with alarms and control panels in accommodation on the bridge. Next is the diesel maneuvering system. It is a complete bridge control system which offers fully automatic remote control of the main engine from the bridge and the engine control system. Next is the diesel protection system. It is a standalone diesel engine slowdown and shutdown safety system for automatic power reduction to protect the propulsion system against the damage. Next is the electronic governance system. It's accurate on controlling the speed in a fuel efficient manner at low revolutions. And we have a propulsion control system which applies integrated machinery control and monitoring. Automatic overspeed reduction in the heavy seas also. So this is a system architecture of a redundant propulsion control system with a control desk. Here you can see we have a control room, we have an engine control room, next is a bridge area, and we have the control system inside the engine room, and most importantly, with the help of this control system we are controlling the propulsion system, and also we have a redundant network. If one network fails, through the other network we will try to control the things. Next, fire alarm detection and alarm system. So this system detects the alarm, fire or smoke in the ship compartments. We have several PLCs connected to the smoke detectors, heat detectors, sounders, and we also have, it is responsible for processing the signals from the detectors and determining the location and severity of the fire and activating the alarm and the required fire suppression systems. So this is the overall view. As you can see, we have a engine room, below deck, main deck, and bridge. This is a simple view. So inside the captain's room, chief engineer's room, main deck, crew, exit room, galley, AC room, tri-store mist. In all these areas we have smoke detectors, and also in the required places we have heat detectors also. And in most exit door locations we have the manual call points also. And most importantly, for the evacuation we are using the sounder alarm systems. So as you can see, we have a main fire alarm control panel and also a repeater. With the help of this 19 to 32 volt DC supply, it is operating, and with the help of the Ethernet cables we are establishing the communications. And most importantly, through the different fire alarm controllers, different loops have been established. As you can see, we have 4 different loops. And sometimes if it is we are taking for the longest distance, we are going for the repeaters. Next, what happens when a fire is detected on an onboard ship? First thing is that it activates the fire alarm or the emergency alarm. First and foremost thing is that we need to find the origin of the fire. And all the engine room members will be informed regarding the fire. Next, if any sort of initial attack must be backed up with the second most substantial means of attack. So water must be used whenever required. Because it most importantly, the ship stability should not be affected if you are using the water. Next is the fixed fire installation system can be used for the initial attack on the cargo hold fires, say for example sprinklers. And most importantly, fire must be confined to the space in which it was originated. Finally, after fire is out, okay, overhauling begins and check the structural damages. All the firefighting equipments are replenished. Okay, if the fire is considerable and immense, sound fire alarm system, evacuate all the engine room staffs, count them and assign them as a master list. Remote stopping of all the fuel pumps to be done, and remote closing of all quick closing valves to be done, and remote closing of all skylight doors and engine room watertight doors to be done, remote closing of all ER ventilation dampers to be done, prime movers and all the machineries to be stopped, all the engine room entry and exit doors to be closed perfectly, all the engine room ventilation fans to be stopped manually, and the fixed installation system to be operated in a proper manner. So during the fire alarm detection in the alarm system, okay, the system should have a manual call points. It should operate immediately at all times. Okay, and most importantly, this if you are providing the power supply to this fire alarm control panels, it should have a redundant power supply. Okay, it should have a two sources of power supply. If there occurs a failure in one system, through the other system it should operate. And also, most importantly, the control panel should be located on the bridge for the easy access. And also heat detectors, smoke detectors, or the other combination of flames we are using, means it should be operated by the it is a combination so that everyone can able to operate it. Okay, and we have so many types of detectors we are using in ships, mostly this smoke detectors, heat detectors, flame detectors. Okay, mostly smoke detectors are installed in stairway, corridor, escape routes in accommodation places. Heat detectors are mostly installed in boiler rooms, laundry, control room, galley. Okay, and these flame detectors are fitted near the fuel handling equipments. Okay, these are ultraviolet infrared radiation. So maximum floor area that can be covered by a smoke detector is 74 mm square, and maximum distance between the smoke detectors can be from 11 meters. If you are going for heat detectors, so the maximum floor area per detector is 37 mm square. Okay, and for this maximum distance between the heat detectors can be from 9 meters. So using the bimetallic strip, this heat detector is working. Next is the combustible detectors. Mostly it is installed in galley and engine room forward bulkhead. There are three different types: fixed temperature, rate of temperature combination, or a combination of the both. So it is moving into the tropical region or heating switch on. Okay, and also normally we used to test this using this hot air blowers also. Okay, next rate of temperature rise detectors. There is a pneumatic type. So increase in the temperature, increase the air pressure inside this copper hemispherical bulb. If the air blood through the two-way bleed valve is sufficient, diaphragm will move up and close the contact. Okay, so we can make the adjustments. So temperature adjustments can be from 55 degree to 70 degrees also. Next is a bimetallic coil tab. It is a two bimetallic coil which are attached to the vertical support brackets, and upper coil in the better insulated from heater than the lower coils. When the temperature increases, the lower coil will move to close contact. Okay, next is a fixed temperature detectors. This is a quadratic bulb fitted with the sprinkler system. Okay, so these are the fixed point detectors which is used in the places other than the engine and the boiler rooms, where we can spray the water immediately. Next is the flame detectors. So these flames have a characteristic flicker frequency of about 25 Hz. So flickering radiation from the flame reaches when the flickering radiation from the flame reaches the filter unit, which allows the infrared rays to pass and focused upon the cell. Signals from the cells go into the amplifiers, which is in turn tuned to 25 Hz, then into the time delay and the alarm circuits. To minimize a fire alarm, fire has to be present for predefined period. Next, if you are going into the smoke detectors, light scatters, light obstructions can be done. Next, light scattering type. So the photocell is separated by a barrier from a semiconductor. Okay, flashing light source are housed inside the enclosures, allowing the smoke but not the light inside. When the smoke is present in the container, light is scattered around the barrier onto the photocells and the alarm is triggered. Okay, photocells and the light sources are vulnerable to vibration and dirt, so test must be done using the cigarette smokes also. Next, if you are going for a fire alarm control panel, okay, so permanently exhibited on board and guidance of officials is very much important. Okay, and also when you're going for a fire alarm control plan, which can include fire alarm control station, various fire sections which can be included into class A and class B categories, particularly the fire detection, the alarm systems, sprinkler installation and the fire extinguishing appliances, means of escapes, that is ventilation system, including the position and number of fan controls and the dampers. when you're going for a generator control system, okay, it consists of several PLCs and sensors and actuators, even HMAs we are using. So mostly for the monitoring and controlling of the ship's generator, we are using this generator control system. Okay, and most importantly, in the generator control system, okay, it is responsible for starting and stopping of the generators, synchronizing them with the power grid and controlling their output voltage and frequency. And most importantly, during the safety interlocks and in case of abnormal condition and emergencies, it plays an important role. It raises the alarms. Okay, this is how electric propulsion systems overview. Okay, now so when we get into the program, PLC program of a generator control system, first we have a startup sequence. During that, the operator initiates the startup. So the PLC activates the fuel supply and ignition system. It monitors the engine speed and the temperature and ensures that generator is synchronized with the power grid. Second is the load sharing. So the PLC program is made in such a way it monitors the power demand and redistributes them among the available generators, ensure that load is balanced and no generator is overloaded. Next is the voltage and the frequency control. It adjusts the voltage and the frequency of the generator based on the power demand and the grid voltage and the frequency, ensuring that power supply is stable and reliable. Next is the safety interlock, such as overspeed protection, okay, under voltage protection, over current protection, so which prevents the generator from the damage and it ensures the safety of the crew and the ship. Next is the cargo pump system. Okay, PLC based system which controls the loading and unloading of cargo from ship tanks. It consists of PLCs, sensors, valves, pumps, even HMIs. Okay, so using the PLC program, this cargo pump control system, which is responsible for controlling the flow rate, pressure, temperature of the cargo, as well as monitor the level, density and viscosity of the cargo. Okay, and also it provides the alarms and safety interlocks in case of overfilling, leakage and other hazards. Okay, so this is how it looks like. It's the overall view. Okay, next this is another view where the cargo system control panel, how it looks like. We have the manual set pressure points. We have the PLCs which drives the valves, okay, which also using the proportional integral derivative PID loop, it controls the valve. Okay, it controls from the pressure transfer, it takes the input and it controls the valves. Next, how this cargo control system works. So first startup sequence is that the operator initiates the cargo handling operation. Okay, so the PLC program activates the pump, it opens the valve and start the flow of cargo from tank to loading or unloading system. Okay, the PLC program monitor the cargo flow rate, pressure, temperature and adjust the pump speed and valve position according to ensure the smooth and efficient operation. Next is the level control. So we have a program, okay, we use level sensors to monitor the cargo level in the tank, loading and unloading and adjust the flow rate and valve position to maintain the constant level and prevent overfilling or spilling. Okay, we also provide safety alarms and safety interlocks in case of high or low level pump failure and other abnormal conditions. Next, density and viscosity control. So it uses the density and viscosity sensors to monitor the properties of the cargo and adjust the flow rate and pump speed according to ensure the cargo is pumped at the right density and viscosity. Okay, so it is important that liquids that are sensitive to temperature and pressure changes. Next is safety interlock. So it provides a safety interlock in such a way that emergency stop, over pressure protection, over temperature protection, leakage reduction to prevent the damage to the cargo and the ship and ensures the safety of the crew and the environment. Next is the ballast control system. Okay, it controls the flow of water into and out of the ballast tanks to adjust the ship's trim and stability. So it is responsible for monitoring the level, pressure, temperature of the ballast water and adjusting the valves and pumps to maintain the desired level and stability. So this is how the overall closed loop of a ballast control system looks like. Next, this is also the typical overview. We have a flushing pump, we have a ballast water treatment, we have a ballast water pump, okay, we have stainers to maintain, okay, the balance of the ship. Next, if you get into the PLC program of a ballast control system, okay, it controls and monitors the inputs and outputs from the sensors and give the command outputs to the actuators. Using PLC or functional block also we can create all these types of programs. Okay, so we use sensors to measure the level, pressure and the temperature okay, and detect any sort of leakages or malfunctions. And also this valves and pumps, okay, it controls the flow of water into and out of the ballast tanks. Okay, the program sends the output signal to the actuator module, which opens or closes the valve and adjusts the pump speed based on the data from the sensor. Say for example, if the program detects a ship is listing on one side, it might send a command to open a valve on the opposite side to let the water and in the balancer ship. Next, we use the HMIs for the ship crew for the with the touchscreen display, so that they will know the exact status of the ballast system, which allows the crew to adjust the settings as needed. Next, navigation system, it controls the ship navigation position, including the autopilot, GPS and radar system. Okay, it is responsible for receiving and processing the sensor data, sending commands to steering and propulsion system to maintain the desired course and speed. So this is how it's looked at. We have a controller, we have actuators, we have a guidance system, we have an observation system, and we have a navigation system. Okay. Next, wastewater treatment. Okay, so in using the PLC, okay, we process the ship's wastewater and solid waste, including the sewage, grey water and the food waste also. So wastewater system is responsible for monitoring the flow, level and quality of waste and adjust the pump, filters and treatment chemicals to maintain the desired treatment efficiency and environmental standards. Okay, this is how it looks like. We'll have a primary and we have a aeration chamber, we have a hoppers and we have a float switches also. Okay. Next, how this wastewater treatment system works, how it is monitored and controlled. First thing is that using different sensors, we will take the inputs, and using the actuators, we will make the commands. Okay, and most importantly, we are using the sensors to measure the level and quality of wastewater and sludges, and to detect any malfunctions in the system. We are using the sensors. If we are going for a treatment process, okay, it processes the waste generated on the ships, including screening, sedimentation, biological treatment and disinfection. Okay, so output signals will be sent to the actuators, which controls the pump, valve and other equipments involved in treatment process. Say for example, it send a command to start a pump to transfer the wastewater to the screening unit, or it adjusts the flow rate of the air to the biological treatment unit based on the oxygen level, which is being measured by the sensors. And we also have the HMI for monitoring and controlling purpose for the ship crews. With the help of a touchscreen display, it will show the status and of the treatment system, and it allows the crew to adjust the settings as needed. Next is the heat, ventilation, air conditioning system. Okay, it controls the ship's temperature, humidity and air quality, and adjusts the ventilation and cooling system to provide a comfortable and a healthy environment for the crew. Okay, so HVAC system is responsible for monitoring the temperature, humidity, airflow and adjusting the fans, dampers and the valves to maintain the desired condition. So how a program works? The first is that we need to control and monitor the with the help of sensors input, and we are controlling the actuators. Okay, so mostly using sensors, we will try to measure temperature, humidity, pressure and air quality at different areas of the ship. Say for example, a temperature sensor might be placed in an engine room, and a humidity sensor might be placed in the crew quarters. Next, HVAC process. So most importantly, okay, using PLC program, okay, using output signals, we used to command the actuators, air conditioning units, fans and dampers. Okay, using PID loops, we used to control the entire process of this HVAC system. We might write a program to send a command to start air conditioning unit in the crew quarters, and when the temperature exceeds a set point, we need to adjust the fan speed based on the differential pressure between the engine room and the other areas of the ships. So we are using the human machine interface HMI system for monitoring and controlling. So it will be useful for the ship crews. All the status will be displayed on this, so that if whenever required any sort of adjustments, they can make using this HMI screens. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We have provided the contact details here. We, LNP Renewable System Integrator, we are providing PLC programming training for Siemens, Allenburn, Delta PLCs. And if you had a plan to work in GCC countries like Qatar, Oman, Saudi, especially in building management system, building automation control system, you can contact us. And if the EB power is not available, using the solar DC lighting system, you can establish. And if you are really interested to learn the basics of access control system and electrical technologies, ship automation, you can contact us. We can provide the contact details here. And most importantly, if you had a plan to establish a electrical fencing, instead of electrical fencing, you can use solar electrical fences in the agriculture farms to protect your crops from the wild animals. We are also providing solar on-grid, off-grid, hybrid applications, retail pump services, design, installation, testing and commissioning, consultancy, training supports also. So if you are really interested, if you are a college student from electrical and electronic background, electronic instrumentation background, or electronic and communication background, you are really interested to get into the automation industry to learn how to do the programming of the PLCs and different technologies, you can contact us. We had provided the contact details. Thank you so much.